Welcome back, everyone, to the second video now in our review on probability from AP Statistics. This video specifically is going to talk about conditional probability. Conditional probability itself is a very small portion of this unit, but it is one that is incredibly important to have a good understanding of, and looking for things like keywords to tell you when to use it. Is going to be something I'm going to talk about in this video. So let's jump right in and take a look at it. Now, the notation for conditional you saw in the previous video is just something like this with a vertical bar. All right, what's important is that vertical bar means given, right? And I talked about that in the video before this, but the definition of conditional probability is literally the probability that an event will occur given that another event has already happened. So that's why I use the word given for that vertical bar that you will see. Now, also remember that this formula is on your formula sheet. However, most of the examples that you're going to see, most of them I say, because there are other ones where if you're given just straight up numbers, you may have to use it. Most of the time, you don't actually end up using the formula directly as you would think. So the formula itself looks like this. The probability of A given B is the probability of A and B divided by the probability of B. That formula is on your formula sheet. What's not on your formula sheet is actually the formula for AND, because what they figure is that you can derive the formula for AND by multiplying both sides by the denominator here. But one thing I want to highlight is that in these scenarios, you always divide by what you're given. That is an incredibly important thing to recognize. Whatever you're given, that's what you'll divide by. And in reality, when you're using both of these, or if you're using this formula in this context, you have to be given 2 out of the 3 pieces in order to find the missing one. So as you're reading the problem, start to look for what pieces are you given. Are you given the conditional and the probability of B? Are you given the and the probability of B? Are you given the and the conditional? Right? What are the pieces that you're given, and then how are you going to use those to solve for what you're missing? So let's take a look at some of the examples that you might see. And I have the exam years on here as well. So the first one is a tree diagram type problem. Now, again, in the previous video, the one right before this, I mentioned tree diagrams being helpful for a sample space. If you see a problem phrased like this, jump to a tree diagram. Anything about testing for a disease or a medication or anything like that, jump to a tree diagram. So we've got a lab test for the detection of a certain disease, gives a positive result 5% of the time for people who don't have it, so a false positive. The test gives a negative result 0.3% of the time for the people who do have it. Now, this is also important here. The large-scale studies show that the disease occurs in about 2% of people. Now, for part A, we're just finding the probability that someone would test positive, and we'll talk about that in a second. But part B is the conditional part. What is the probability that someone who tests positive does not have it? This part right here is my given. So given that they test positive, what is the probability that they don't have the disease? So I have a blank page here for us to be able to actually go through this. So if I take a look at this, we either have the disease or we don't have the disease. And then based on that, we either test positive or we test negative. Now, if I remember correctly, I believe it said 2% of the population has the disease. So that means 98% of people don't have it. And then the false positive rate is 5%. And then the false negative rate is 0.3%. And that is very, very important. Not 30%. It's not 0.3. It's 0.003. And so, in this particular case, what is, for part A, what is the probability that someone will test positive? Well, that happens two ways. They either have the disease and they test positive, or they don't have the disease and they test positive. So in this case, we've got, what is this here? 0.02 times 0.997 plus 0.98 times 0.05. Now, for the purposes of this question, I have no idea what that answer is. And I'm also not going to find it. But you would use your calculator, you would get that answer. It's going to be a relatively small-ish number. Yeah, right, maybe around 10%. We'll see, right? Part B is the important thing, because part B is what's the probability that somebody does not have the disease given that they test positive, right? Find the probability that a person selected at random who tests positive does not have it. So given that I test positive, what is the probability that I do not have the disease? So if I use my formula directly, that is the probability of no disease and testing positive over the probability of positive. And so when I plug into my formula here, we know no disease and positive. We just got this from the previous part. And then whatever answer you got from part A, that was the probability of testing positive. So this is one way that you will take the conditional probability formula and use it directly, is like this. The nice part about a lot of these questions is that part A, you'll calculate a number and then you'll typically use it in part B, so you don't have to recalculate that probability of testing positive. It does make your life a little bit easier. So again, this is a way that you will use the formula directly with a tree diagram type question. The other type of problem you might see is a problem with a table, right? And now this one is a little bit more obvious, where it says literally the word given that a randomly selected registered voter is a male, what is the probability that he is registered for party Y? The one reason why I bring up this type of question is that if you're in a table scenario, the given just sticks you in a row or a column, depending on what you're given. So in this case, I was given that it was a male, so I know there were 200 guys in the study, so I know my denominator is 200. How many of those guys were registered for party Y? Well, that was 48. Now, the nice part about probability on the exam, you do not have to simplify that fraction to get 24% or 0.24. You can put it as a decimal, or you can leave it as an unsimplified fraction. And if you remember from class, this is something we talked about, where this actually gives me more information than reducing this to whatever it ends up being, 24 out of 100, 12 out of 50, 6 out of 25, right? Something like that. Because this tells me that there's 200 guys in the study and 48 of them are registered for party Y. And now, the other reason why I use this question, even though it is old, it's newer than the previous one, is that now we can use our conditional formula to check independence. Because are these two things independent? Well, if they were, that would mean that the probability of male would equal the probability of male, the probability, I flipped this around in my head. This would mean the probability of being party Y would be equal to the probability of being male. Nope. It would be probability of party Y given male. I just can't read apparently. So, well, what's the probability of being a part of party Y? That's 168 out of 500. That does not equal 48 out of 200. So now they are not independent. So these are the two types of questions that you will see typically that deal with conditional probability. Being completely honest, this tree diagram is the most common one. That table one tends to show up on multiple choice questions more than free response questions, but it may still be there, as you saw. So again, I hope that was helpful, and I'll see you in the next one.